Hello everyone, in this video we are going to be talking about this Tang Nano FPGA series, and you can see that I'm not in the usual background because I've came home. And Merry Christmas to everyone. This video is probably going to be dropped around Christmas, so Merry Christmas to you all. And let's see, let's get into knowing this FPGA board. So this Tang Nano FPGA series is basically one of the most affordable lineups that you can see on the internet, and you can buy these boards in 3 or 4 variants. The main variants are 1K, 4K and 9K, and the 4K variant has a hardcore MCU in it as well. I'll explain to you what that means. And the 1K series is the cheapest. The 4K, the 1K and 9K in numbering in this series basically represents the number of logic cells. Okay, logic cells you can roughly consider LUTs only. Being so affordable, these FPGA boards can be one of the best starting points for many of you guys, because the Xilinx FPGA boards, as I've already told you, those are very expensive. If your lab does not have those Xilinx FPGA boards and you do not have access to much of FPGA boards, these boards can be very nice for starting off. In my 100 days of FPGA series as well, I've used Xilinx FPGAs, right? Today we will see whether you can follow along those videos using these FPGAs, and we'll test the entire thing in our setup. We'll basically put some designs on it, and we'll see whether you can easily design using these and learn FPGA development using these. So today we'll basically see how we can get started in this board. We'll install all the necessary requirements, IDs and everything, and we'll run 3 basic examples on this board. So I'll make 3 to 4 videos in this Tang Nano series of videos, and in this video we will see the basic 3 examples. In the next video I'll try to run a fast Fourier transform example, and in one more video I'll try to run a neural network accelerator as well. But starting off, we need to start with the basics. So let's go and see how do we install the IDE. So the IDE that we basically use with this FPGA board is Govin EDA. Let's install it. We'll go into download Govin EDA. I'll go into this website. So first off, you need to basically register or login. So we'll go here and register. Here, if you want to create, if you do not have an account, you will create an account using this menu. Here, since I already have an account, I'll basically log in. Alright, so I've logged in my account, and I'll go to that download page again. So we'll go. So there are 2 things. We need to download the ID, and we also need to download the license. Okay, so first off, let's download the ID. We'll download it from here. And if you go software for Windows, depending if you have Linux, you can go here and choose Linux or Mac. Since I have Windows, I'll go here and we'll do this. So we'll basically download this. Go here and click here. It will start the download, and just save it. Okay, so the setup is downloaded. We'll extract it. Since I've already have this file, I'll just replace it. This is the extracted file. We'll basically install it. Okay, so run the installer. Go into, these are all the usual steps that you need to do once you install it. Just choose the file and install. Let it install. So once we install it, we'll see how to include the license and everything. So this is done. Now, as you can see, this Govin ID is installed. If you open it, license validation field, file cannot be opened is will show this. Okay, so you need a license.lik file again in here so as to run this entire thing. Okay, so let's see how we get the license file. Go into apply license and basically fill all of these information. Okay, fill the entire information and select this Govin EDA thing, and in here you will basically have first license for this machine and MAC. In the PC MAC address, you need to get the MAC address of the device on which you will work. So for getting the MAC address, go into command prompt. Okay, so just type cmd and ipconfig/all, and you will see all the IP addresses over here. Go into top and you will see the physical address. This physical address is the MAC address of your computer adapter, and basically take this address and paste it over here in the PC MAC address section. And once you do that, you basically submit, and you will get the license key on your Gmail. Okay, so you will get an email like this. After it will take around 1 to 2 days to get the license file. So the email looks like this. It is basically something like this, and here in the attachment you will have the .lick file. We'll download it. All right, so after downloading the lick file, just double click on this icon, and what you will see is, you'll see this license manager. Okay, so you need to provide the location of the license. So right now my license is in the downloads, so I'll just select that and just select this. Okay, and I'll press check, and license is okay. Okay, now save it and done. Now if I again open it, you can see the Govin ID is basically opening right now, and this is how you set up the Govin ID. Basically you need to download the ID, install the ID, and you need to have the license .lick file. For getting the lick file, as I shown you, you need to provide all the information, the PC MAC address, and they will email the file to you, and you just download it and provide the part to the file, and this will basically open. Now since we have the ID installed, let's design some of the basic projects on our board, and let's see the working. Alright, so the first design that we will put on this FPGA board is going to be the AND gate design. So go into the new project. Here FPGA design project, we'll write the name. We'll write the name as now. Here you need to give the part number. So how do you find the part number? Take your FPGA board. Here on the board you can see it's written GW. Go into the next and finish. So as we have this open, I'll go in here, we'll do new file, and we'll select Verilog file. Just do OK, and in here I'll write AND gate and OK. So in the 100 days of FPGA series, I've already told you how you can design AND gate and everything from basic like buffer and all the combination logic I've already covered. So you can basically see those videos as well. Here I'll show you again how I will design an AND gate. So I'll do module. I'll have Y as the output, A and B as the input, and since this is combinational, Y will do assign Y equal to A and B. So our AND gate design is completed. We'll basically see how we implement it on the FPGA now. So we'll select this, go into processes, you do synthesis. Okay, double click on the synthesize option, you'll see this is synthesized now. Alright, so one more thing that I wanted to show is, if you go into the tools and go into schematic viewer in RTL design viewer, you can see the design that you have created in Verilog. So this feature is also available in this ID, so this is very nice. Alright, so we have designed everything in Verilog. Now we need to implement it on the FPGA. So for implementation, what we need to do, we need to provide the constraints file, right? In Xilinx, in the Vivado, we used to basically have a constraints.xgc file. We used to add sources and we used to include the file. Here also you can do that. Here it is called .cst file actually. So .cst file you can physically include, and also you have the floor planner window for that. So I'll show you both. What you need to do is you go here in the process and you basically double click the floor planner, and here it says this project doesn't include the CST file because we haven't created one, right? So it says, do you want to create a default one? So we'll basically press OK, and here we will assign all the values. So once you go here, you have two methods again. You can basically physically go into the ports and you can drag and drop into one of these pins, and that will work. As you see, as you saw here, it basically took the pin number automatically, right? You can do that. Otherwise what you can do is you can just type the port names here. Okay, if you don't see this entire window, you might be in the messages window. You can go into IO constraints and you will see this entire thing. So here in the output, our output is LED, right? So our LED is pin number 10th. You will write pin number 10, and our A and B, we have two push buttons on the board. These push buttons have a pin number of 14 and 15. I'll edit those. And here, one more thing that you need to do is the bank voltage of the output LED is 3.3 volts. So I will change that in here. So you can change bank voltages and everything over here as well. And along with that, you have pull mode, up and down, and everything you can do. Also, these push buttons on the board, basically, if you see, these push buttons are inverted. Okay, what I mean by that is, these push buttons, when you push them, it will become 0. When you do not press them, they are basically 1. Okay, so they are kind of opposite of how normal push buttons work. So on these boards, that is how it is working. It will get reflected in the testing phase as well. We'll see that. Now here, if you see, we'll basically save it and go into place and route. Double click the place and route, and here we should be good. Okay, as you saw, place and route is done. And what we can do now is we can connect the FPGA in our laptop and we can program it. So here I plugged in my board, and now I'll go into programmer. So here, if I press the programmer, just select the save, and here go select this, and just select this program configure button. So once I program this, and it is programmed. So as you can see here, we have the LED on right now. This is an AND gate, right? But since all the inputs are inverted, A and B inputs are inverted, you basically have modified truth table, which I'll put on the screen right here. If I press any one of these, basically what is happening is that it is becoming 0, right? So that is why AND logic is pulling this LED to low, and if I have both as low, the LED is low, right? So the push buttons are basically inverted. So that is kind of counterintuitive, but if you once you get the hold of it, you will understand. So this is AND gate implementation on the Tang Nano FPGA. Alright, so as you saw the AND gate implementation, the push buttons were kind of inverted, so you saw that logic. What you can do to compensate that is you can add a NOT here in place of these. So in place of A, you can add NOT A and NOT B and all that, but I'll leave that up to you, so you can try that on the board. What I will show up next is the blink example. In the last in day 16 of the 100-day FPGA series, I've shown you how you can basically blink an LED on the FPGA, and I've explained how you basically count the number of cycles and write the entire code. So I'll not write the entire code line by line here, but you can go into that video and see how that works. Okay, here I will just show you how the blink LED is being implemented on this board. So let's see. As you can see, we have basically implemented a counter. In that video as well, I've basically showed you how you can basically count this number of cycles thing. Here it is 27 million, because the default clock rate on this board is 27 megahertz. So that is why counting 27 million times, you can basically count 1 second, right? So I've toggled the LED. As soon as I count up to that many steps, as soon as the LED it toggles, you also basically reset the counter. When the counter is not your specified values, you basically increment to that value, right? If I show you the constraint file over here, you can go into floor planner, and here the clock number, pin number is basically 45. So I've written 45. It is bank voltage is again 3.3 volt in the clock as well. In the LED, it was 3.3 volt, and the pin number was 10. And I've also added a reset, which is push button number 14, and that is basically 1.8 volts. Okay, bank voltage. So this is the constraint file. Now let's put this blink project on the FPGA, and let's see the working. So I'll program the FPGA. Okay, so the FPGA is programmed now, and as you can see, the LED is blinking with a time period of 2, and this is how the blink LED code is basically implemented on the FPGA. And as you can see, this is working. Alright, so in the last two examples I showed you how you can implement AND gate, and how you can implement blink example. So one combinational logic, one sequential logic I've showed you on the Tang Nano FPGA. So those are the basic examples. I'll show you one more example, which is UART transmitter on this FPGA. So I wanted to include one more thing, like apart from these basic things, I also wanted to show one of those protocols being implemented on this board. So I'll put a UART transmitter on this board and I'll run it, and we'll see the waveforms on the waveform software. So let's do that. Okay, so as you can see, this is the UART transmitter module. So basically I've not modified nothing in here. I've just modified this clock speed. Okay, this module I had written for Xilinx FPGA. I had written this long ago, and that time I was learning UART and all. So this basically as you can see, this is a kind of unpolished thing, but this works. Okay, only two changes I've done. I've taken this clock speed as 27 megahertz because the base clock is 27 megahertz over here, and in Xilinx one it is usually 100. In here, another thing that I've changed is this trigger. Okay, so this is trigger inverted. As I told you, the push buttons are inverted in here, so that for the triggering, what I've done is basically just taken the input and inverted the switch. Okay, push button, so that will see the working. I'll basically put this on the FPGA. As you can see, the place and route and everything is done clearly, and if you see the CST file, this is the CST file. Okay, I forgot to tell you about this. When you go into the floor planner, and when you go into IO constraints and everything, and you basically define all these pin numbers, what is happening is that it is basically being written in the CST file. Okay, Xilinx also has this kind of system in their Vivado. If you go into Vivado, you will have IO constraints, and there you can also basically take one port and assign it, and that will automatically get added into the constraint file, .xdc file, right? So that method is also there. So you can here also the similar kind of flow is there. If you change it, if you change the IO constraints from here, it will get reflected in the .cst file, which is here. Okay, and you can directly write the .cst file as well if you do not want to go into the floor plan. That depends on your style. Next off, as you can see, the pin constraints over here. This reset is basically pin number 14, trigger is pin number 15, which are the push buttons. Transmitter on here is one of the pins. Okay, so on the Tang Nano FPGA, as you can see, we have lots of headers, and we can use many of those as IOs. Okay, so I've used one of them, and in the clock you again have 45 as the pin number. So here you can see I've basically inverted the reset as well, because the push button is inverted, right? So I'll put it on the FPGA, and we'll see the UART transmitter working on the Tang Nano FPGA. Alright, so I programmed the UART transmitter on the Tang Nano FPGA, and here this is the output pin and this is the ground pin. I've connected it to Analog Discovery, and we will see the waveforms in the waveform software. Basically the output we are going to see in the waveform software over here. And basically what I'm going to do, I'm going to push this push button on here. This is the trigger. Okay, as soon as I push this button, the FPGA is going to send one random byte through the UART protocol. Okay, so I'll push it and you will see the output. Okay, as you saw, as soon as I'm pushing it, that is appearing, and I will stop it so that you can have a nice look. If I stop it and zoom out, here you can see this is the byte being transmitted through the UART protocol, and this byte is basically random byte which I have assigned in this Verilog code. What I've done is that I've taken one LFSR, which is linear feedback shift register. I've taken this LFSR. This LFSR basically what it is doing is it is generating a random byte every passage of the clock. Okay, so as you can see, this is the LFSR that is producing random numbers, and this number, which is the transmitting byte, this is basically transmitting it through the FPGA, right? So this is how it is happening, and as you saw in the waveform software, we are basically getting the UART signals. Alright, so I've shown you 3 examples on this FPGA board, and as you saw, it was very easy to basically design everything and implement it on the FPGAs, right? So what are the concepts that I have explained in the 100 days of FPGA, you can basically take this FPGA also and you can apply it on here, and you can follow the entire series on this FPGA as well. And this FPGA costs very less, like it is very affordable. So you can start your FPGA learning journey using this FPGA as well. Okay, in this video, as you saw, I have basically run all the 3 designs. In the coming videos, I'll basically make 1 or 2 more videos, or maybe even more if you guys demand. I'm going to make 1 or 2 videos, and there I'll basically have more complex designs such as fast Fourier transforms. And as you can see here in this board, you also have an HDMI port, right? This is a Tang Nano 4K. If you have seen my FFT video, there in the Z board I basically implemented the fast Fourier transform, and I had used many HDMI IPs to basically display the fast Fourier transform on the monitor, right? So we'll try to do that on this board as well, since we have an HDMI port here as well. So we'll try to do that. I'll also try to put a neural network accelerator on this FPGA and try to basically run that as well. So let's see. So in the coming days as well, I'm going to make more videos on this Tang Nano FPGA board, and I'm going to explore more such cheaper boards, so that beginners and those who are starting off, those who do not have access to the labs and everything as Xilinx FPGAs, you can basically learn through these as well. So I've also ordered Strike Lite, so I'm going to make a video on that. That is the cheapest board, so I'm pretty excited about that as well. If designing and implementing stuff on Strike Lite is as easy as the Tang Nano, then that will be a game changer, right, for learners and everyone. So I'm going to make videos on Strike Lite as well. So till then, stay tuned, everyone. Subscribe if you haven't, for more such exciting videos on hardware, and thanks for watching.